Hey guys, Miss Wallace here. This week we're going to talk a little bit about fossil fuels. We're kind of building upon our lessons from last week when we talked about landforms. We talked about weathering, erosion, and deposition. And we have to talk about those first because you have to have weathering, or the breaking down of rocks into sediment, the erosion, which is moving it to a new location, and then the deposition of dropping it off. We have to have those happen before we can talk about fossil fuels. And the reason why is because we're going to have this deposition, or this building up of layers of sediment on top of organic matter that's going to lead to the formation of fossil fuels. So let's talk about fossil fuels a little bit. We call them fossil fuels because they're actually made from the organic matter of decomposed or dead plants or animals, okay? And we'll talk about the specifics of each of these in just a second. We know that this is material that's been buried way down deep in the ground, and it's been there for thousands of years. So you have to have an extremely long time period. You have to have lots of layers of sediment on top of this organic matter that's eventually going to put a whole lot of pressure, and it's going to create a whole lot of heat. And this is called compaction, okay? So when we study our WEDCC, this is that first C, compaction. As I continue to build up layer upon layer, it's just putting more pressure and more heat down below. You can think of it as like if you were to dogpile somebody, right? If you have a brother or sister and we had 20 people that dogpiled them, they would have a lot of pressure. They would feel a lot of pressure at the bottom of that stack, and heat's also going to build up. Now, the problem with fossil fuels is the pollution. They pollute the environment when we burn these for energy. And unfortunately, here in America, we are very dependent on our fossil fuels for energy. I myself just put gasoline in my car yesterday. That way I can make it to school. So we need to start looking at more alternative sources of energy. And those are called renewable resources, meaning that we can get more and more and more. Your fossil fuels are considered non-renewable resources, meaning once we use them up, then they're gone. It takes way too long for more of these to form. So let's take a look at each of these. I wrote the con real big, your C, your O, and your N. We call these con because they're bad, right? So if you think of pros and cons are usually the negative side of things. So fossil fuels are our cons, and this is to help you remember coal, oil, and natural gas. So coal is actually going to be found in areas where there used to be ancient swamps, and it's going to be dead or decaying plant material buried down deep in the ground. So the reason why I drew like a vine on the C is to help you remember that coal is coming from dead, decaying plant material, and there's not really a coalberry bush, but if coal could grow on a bush, that's what we're doing here to remind ourselves coal is coming from plants, okay? So coal, when it forms, has to go through a process. If you read your Stemscopedia, you saw where it has it has to be converted into peat, P-E-A-T. And there's several different steps to that process. But coal, when we mine it out of the ground, is actually a rock. And so that's unique. So coal is kind of on its own over here. Then we move to oil and natural gas. These two are going to be very similar. They're both made from microscopic sea life that has died, drifted to the bottom of the ocean, been covered by layers of sediment. Now, a lot of people think fossil fuels, oh, that's got to be dead dinosaurs. It's not dinosaurs, guys. We're talking about microscopic, very, very tiny. You cannot see it with your eye. You must have a microscope. Sea life, and these are called diatoms. And I'm going to show you a picture of what diatoms look like. These are some examples here. They're very, very tiny. They're one of nature's wonders as far as their geometric patterns and their symmetry. They're incredible little organisms. But these are living creatures, and they're in the trillions in the oceans, okay? We still have them. As these die and they settle to the bottom, you're going to have just tons of amounts of these dead, and they're piling up, and then you have more layers of sediment. And so this is what's going to be decomposing into the oil that we're talking about, or the natural gas. Now, where you find oil, a lot of times you will find natural gas close in proximity to it. Reason being because they're both made from the same things, right? But if we have a pocket that we have extreme heat and extreme pressure, a little P got cut off there, that's when we actually have this microscopic sea life that's decaying converted to natural gas, okay? Now, one of the myths is that These are found in pockets down deep in the earth. If we could just stick a straw down the earth and we could just slurp out the oil, it doesn't work like that. So when we try to get the oil or the natural gas out of the ground, it's actually kind of interlaced within the rock layers. And so it's really difficult. Right now, we can only get about a quarter of the amount of oil out of an area. So what we have to do is we have to break up that layer of rock to try to get the oil and the natural gas out of it. Okay, I hope this helps you a little bit. This anchor chart is on Google Classroom, so feel free to print it out if you want to. You can color yours, you can draw on it a little bit more. Let me know if you have any questions.